Okay, so 5-4 is distributive property. Distributive property. Raise your hand if you know anything about the distributive property that you could share with the class. Yeah. Good. Anything about the distributive property? Nobody? No one's heard of it. Okay, we'll go right into it then. Okay, so here's an example. I'm not even going to define it. I'm going to let you guys look at it and then we'll kind of define it. So here's an example with just letters. So I have an A, and then in parentheses I have a B plus C, and that will equal AB plus AC. So I started with some separation here, and now they're kind of together. You see what happened? Does anybody know what operation just happened? Okay, Zach. No, not associative with the property. Like, did I add, subtract, multiply, divide? Okay, raise your hand if you think I added. Raise your hand if you think I subtracted. Raise your hand if you think I multiplied. Raise your hand if you think I divided. Okay, let's keep looking. Shh, you guys cannot talk right now. It's recording. Thank you. Just to remind you. So let's look at it with subtraction. I have A times a B minus C, and that will equal AB minus AC. Again, I multiplied, just like the first one. So that's A times a B minus C is equal to AB minus AC. Okay? And you can have a negative on the outside of the parentheses as well. You could have a negative A times the B plus C equals a negative AB minus AC. See how that negative followed through? Okay, so what's going on here is I'm multiplying, and we call this the distributive property because I'm distributing a value through the parentheses. Okay, so this is how the best way to do this. It's called rainbows. So if you love rainbows, here you go on a rainy day. A is going to B, and A is going to C. Draw these little rainbows in on the first one. So that means it's A times B, and it's A times C. And the plus is in the middle. So far, so good? Now the second one, let's draw the rainbows. A times B is AB, right? And A times a negative C is a negative AC. Okay, and then let's look at the third one. Negative A to the B makes a negative AB. And negative A to the positive C makes a negative AC. So far, so good? Okay, so whenever you see me doing this distributive property, you're going to see me draw rainbows. So should you draw rainbows? Yes. Okay. Now, what about if you have all negatives like this? Negative A times negative B minus C. So let's draw our rainbows. So negative times a negative is a positive. We learned that last chapter. And a negative times a negative is a positive. So everything becomes positive. The biggest mistake that the 8th graders make, and some of you will make, is they don't distribute the negative all the way through. They do maybe on the first term, this is called the first term, but they don't do that on the second term, and then they get a positive instead of a negative, or a negative instead of a positive, and it messes the whole thing up. Okay? Let's look at this one. What if you have one negative on the outside, so that would be negative AB. And then a negative times a negative is a positive. So you can have a result where one is negative and one is positive. So basically, the little note I put on the side here says, always distribute the negative. Do not forget about this negative. If it's out on the outside, you must distribute it. Yes. Is the what? This is negative. This is positive. Okay? So always distribute the negative. This distributive property you'll use the rest of this year. You'll use all of next year. And then all through high school, and if you go to college, all through college math classes too. Okay, so you have to get it down. And it's really not difficult. It's just that negative thing. People forget about the negative. Okay. So let's try this with like real numbers because these letters are kind of goofy, right?
Yeah.
Let's try numbers. Okay? So we have this thing and it's called equivalent expressions. It just means you're going to get the same value. Equivalent means equal, right? So if you're going to distribute 2 times x plus 2, so rainbow there and a rainbow there, that's 2x plus 4. So put some numbers in here now. These are equivalent expressions because it's the same value. So if they ask you on the test, like which one is an equivalent expression, you're just looking for the one that has the same value. All right, so here's some numbers. So if you had a problem like this one, example 1, you have 5 times a negative 9 plus 11. You could distribute it, or you could just go, what's 11 minus 9? 2, right? Either way, you're going to get the same answer. This one would be negative 45 plus 55, and this one would just be 10. The second way is a lot easier. But I do this to show you that they will be equivalent, right? Whether you distribute or if you combine your numbers first and multiply, you get the same exact answer. Okay. Any questions on that? All right. Example 2. 4 times x plus 7. X plus 7 in parentheses. So we do 4 times x, and we do 4 times a positive 7. So that will be 4x, and then 4 times 7 is 28. So far, so good? Okay. Example 3. P minus 5 in parentheses times 6 on the outside. I just did this one to show you that you don't have to have the number first. It could be last. But you still do the same thing. So draw your rainbows backwards. So that's 6 times p and 6 times negative 5. So that is 6p minus 30. Any questions on that one? Yeah.
How come you just leave the 6 minus 3? What did you do? Like, you figured you did it.
How come I did what?
How come, like, on example, more example 2, you did 4x plus 20?
Yeah.
Wouldn't you do 4x plus 20 and just like write 32 instead? Or not? You're not understanding why you did that.
I guess I don't understand what you're asking exactly. Are you asking why it goes this way?
No, just like why you wouldn't like plus or minus multiplication. Finishing
This is as far as it can go. This has an x with it, right? This doesn't have an x with it, right? So you can't put them together. It's like apples and oranges.
That makes more sense.
Yeah.
I remember in example 1, you said, like, it says 5 and then, like, parentheses 2.
Yes.
How did you get the parentheses?
Negative 9 plus 11 is 2.
Oh.
I was just proving to you that this works either way, right? Good questions. I like those questions. Okay, let's look at example 4. Now we have a negative. We have a negative on the outside, so we have to distribute it. So this negative times x would be negative 2x, right? And what is negative 2 times negative 8? Positive 16. Good. So there's your answer. Negative 2x plus 16. Negative times a negative is positive. Okay.
What's your parents?
Yes.
On example 3, why is it 6p minus 30, not 30 minus 6p? Like what?
Well, the minus is with the 5, so that has to be with the minus 30.
Oh, okay.
You could write minus 30 plus 6p. I'll even write that for you. That's the same thing. Does that make sense?
Yeah.
Okay. Okay, so some of you, this is the rainbow kind of thing is a little bit confusing because you're like, I haven't seen this before. So I'm going to show you another way that you could actually plug in these numbers and get it right every time as well. Okay, so some people want 2 ways to do this. Okay, so, and I actually put mine on the left side of my page. I don't normally do that, but it's called an area model. So let's look at the first one right here. So if I had 3 times x plus 2, and this, if you want to write out what it would look like, it would look like 3 times x plus 2. And what I did was I drew like a little rectangle with a line down the middle. Can you guys see what I did? And I put the 3 over here and the x plus 2 on the top. Then I know 3 times x is 3x. 3 times a positive 2 is a positive 6. Do you see what I did? I kind of broke it apart. You don't have to do it this way. It's just an option for you. And then the next one, it would be a negative 5 times x minus 4. So I put the negative 5 on the outside, the x minus 4 on the top. And then that's negative 5x. Negative times a negative is a positive. So some people like this better because it kind of like separates their work for them. But like I said, it's totally up to you if you want to use it or not. The last one I put because I want you to see that you don't always have to have a number or letter on the outside. You could just have a negative sign. It just means negative 1, right? So that's a negative times a positive is a negative. A negative times a negative is a positive. Raise your hand if you like this method better. The boxes, it helps you to see it. So some people do. I personally like to just draw rainbows. It makes me happy, right? So that's what I do. But you can do it this way. In elementary school, I don't know if you guys got this far because now they have Common Core has gone and adjusted what you learn when. And I don't know if you got to this in 6th grade, but some of you, I know that they had you do a lot of area models. Do you guys remember when you had to like draw a block of 10 and then shade things in?
Yeah.
Okay, those are called area models. Or, you know, the really icky one that my kids hate is they'll say like draw something to represent the word problem, and it'll say like there's 10 birds, take away 3 birds fly away, and they had to draw like 10 birds and then circle. Do you remember this? They had to like circle and cross it off, and it's really tedious because everybody knows 10 minus 3 is 7, but they made you draw it. Do you remember? that's where it comes from. And so some people that are visual learners, this helps you. This does not help me, but it might help you. Okay? All right. The very last thing, there's one more example, and then you guys are going to try a couple to see if you got it. So, of course, we have to have a fraction, right? Fractions. Okay, so again, we have 1/3 times x minus 6. So we're going to draw rainbows. That way it keeps it separate. So what's 1/3 times x, you guys? Just 1/3 x. And what's 1/3 times negative 6? Negative 2. Good. So it's 1/3 x. And then this 1/3 times a 6. Remember, you can cross cancel. 3 goes into 6 twice. So then that just becomes negative 1 times 2, which is negative 2. Cross canceling, you probably did some of that in 4th grade and then again in 6th grade. So fractions aren't that bad if we know that 3 can go into 6, or say we have 2 and 8, or things that they go into each other, right? They're factors. Okay, so I want you guys to try this in your notes. I want you to try number 1. 6 times a plus 4, and I'd really love it if you drew your rainbows. Raise your hand when you got it. Okay, Nina, what you got?
6a plus 4.
Good, but not 4. 6a plus.
Plus 24.
Yeah, I knew you were going to say that. You just went a little too fast. 6a plus 24. Raise your hand if you got that right. Good. Okay, number 2. M plus 3n times 8. So you could draw your rainbows backwards. Doesn't matter what order. Just raise your hand when you think you have this one. Oh, I might be tricking you a little here. You have to think. Too early to think, huh? Okay, Michael, what do you think?
8m plus 24n.
8m plus 24n, and you are right. Raise your hand if you got that right.
Oh, man.
Question?
Like on number 1, you know how it's like 6a plus 24, why don't we just add those?
Because there's an a on that one and not an a on that one.
Okay. So
Can only put them together if they both have that variable with it.
only if they have the same letter?
Mhm.
Okay.
Yep, same letter. These are different letters, so they don't go together. It's like apples and oranges. Okay? On Thursday, we're going to talk more about that, so I'm glad you guys are noticing that. Okay, number 3. Try this one. Ooh, I put a negative. Oh, my gosh. Negatives. What are you going to do? Raise your hand when you think you have it. This is the one all the 8th graders miss. No pressure. I'm giving people a little bit more time, looking for hands. Okay, Zach.
Negative 3y plus 30.
Perfect. Raise your hand if you got that right. You guys are smarter than the 8th graders today? Awesome. All right, let's try this last one and let's see if you're really smarter than the 8th graders. Number 4. You knew I was going to put a fraction. Come on. and a negative. You could do this. It's just like example 5. You could do it. Just raise your hand when you think you have it. Okay, I'm seeing lots of hands go up. That's good. Okay, Emery, what'd you get?
1/2 W minus 2.
Is she right, everybody? Yeah, good, because 2 goes into 4 twice, and then you have a negative. Raise your hand if you got that right. You are smarter than the 8th graders today. Okay, so here's what you're going to do. The practice, okay, I wrote the practice and the homework down up here. So the practice is page 379, 1 through 12. Page 380, 24 and 25, and then there's your homework.